I don't know why I'm not screen sharing at the moment, but that's all right. We'll get back to that. Welcome back, guys. We are going to pick up with our chemical reactions. Go ahead and make this big. So we are going to be talking about chemical reactions now. The thing with chemical reactions is everything that we talk about, now that we know how to calculate from mass to number of moles to number of molecules, is going to be based in our chemical reactions. So if I can't balance a chemical reaction, we're going to have problems. In order to balance chemical reactions, we have to understand mass balance, meaning that I can't lose stuff. So if I have things on one side of the equation, they have to exist on the other side of the equation. They don't have to be in the same place, but they still have to be there. So I can't just make stuff up and it appears. It has to be there, okay? So we can move stuff around, but it can't just appear or disappear. We have to have that. Now, I need to be able to go from words to formulas, or from formulas to words, to be able to walk between those two things. And so that nomenclature becomes very important. All right. Now, we study chemistry to learn how one atom or molecule is chemically changed into another substance. That's our goal. In order to be able to do that, we need to have a shorthand notation for what that process is and what it looks like. We need to make sure that we have the same number of atoms of each type of on the reactant and the product side. So our reactant side is our left side. Our product side is our right side. We go from reactant to product. Okay. So our reactants are over here. And our products are over here. Okay. So we can talk about H2, hydrogen gas, reacting with O2, oxygen gas, to make H2O, which is water. Okay, we can talk about that process. Now, I know that both hydrogen and oxygen exist in as dimers on their own. Okay, there's some of those gases that we talked about where they're always together on their own. I also know that water is H2O. I know that that's true because hydrogen becomes an H plus, it wants to lose that electron that it has. And when it becomes an H plus, and I want to have that H plus bound to an O2 minus, I need to have two of them to make it electrically neutral. So it's an H2O. But if I say that, if I have H2 and O2 going to H2O, then I have two hydrogens here, and I have two hydrogens here, and I have two oxygens here, and only one there. And oh my goodness, that can't work. So we have to balance this equation. And the only way that I can balance it, knowing that this has to be a dimer, and this has to be a dimer, and this has to be H2O, is to put numbers out in front. Okay. So I have to be able to say, well, I know this looks like this. So I need to have more oxygen on this side. So I need to have two of these to make sure I have the right number of oxygens. So now that I have two oxygens on this side, now this is happy. But now I've screwed up the number of hydrogens. So now I have 2 times those 2, that's 4. So now I have to have 2 over here. So now I have 4 hydrogens on my reactant side and 4 on my product side, and 2 oxygens on the reactant side and 2 oxygens on the product side. And now I'm okay. And that may seem very arbitrary to you. It's like, well, how did you get to that? Well, I understand why that might seem arbitrary. And I understand why it might seem like I just pulled numbers out of everywhere and ended up with that. That's true. It might seem that way. But I have a system. So let me show you what my system is. Okay. But let's talk a little bit more about this stuff. Now, my reactants are my starting material. So I go from reactants to my products, my things that I end up with, what's formed as a result of a chemical reaction. So I have this chemical reaction. And what happens is that I take those atoms and I rearrange them. I haven't destroyed them, I've just moved them around. So I broke some bonds and I made some new ones. Okay. And we often like to include the physical states of these things. And we do that to make calculations that come later, not necessarily this semester, but in 111 possible. Okay. It's important that we talk about what physical states these things are at some point. In order to talk about physical states, we need to know what physical states we can talk about. And we talked about the fact that we have physical states: gas, liquid, solid. Those three we've talked about. And so we symbolize G for gas, L for liquid, S for solid. There's one more that we'll talk about, and that's AQ for materials dissolved in water. So just like we talked about in the lab, right? We had sodium chloride that was dissolved in water, right? It was aqueous, surrounded by water, so aqueous. Okay, that's NaCl solid was then dissolved into water to make it NaCl aqueous. And then, of course, it can actually come apart when it's in there. So that happens too. So we can talk about that process, and we will eventually. Okay, we'll get there. But that's what we're talking about when we talk about that. So these are states that will include, so 2CO gas plus O2 gas goes to 2CO2 gas. Okay. Now, is it mandatory that we do that at this point? No, it absolutely is not. Am I going to grade on that? Absolutely not. But it's a good habit to get in, because it will be very important that you consider those physical states when we talk about Chem 111, because we're going to start doing calculations for things like equilibrium constants. And you will need to know what is a gas, what is a liquid, what is aqueous, what is a solid, because some of those things appear in an equilibrium constant and some of them don't. So we'll need to consider that, okay? And of course, when we talk about some of the other math that we do in 111, it'll be different depending on what phase it's in, because it takes a lot more energy to do something into the gas phase than it does to do it into the liquid phase or into the solid phase. So we need to understand what phase we're doing it into to understand how much energy it's going to take. Okay, so that becomes important. At this point, we're not overly concerned about it, but it becomes a good habit to get into. All right, having said all of that, we need to be able to balance our equations. When we talk about chemical equations, we need to identify all of our reactants and our products and write their correct chemical formulas on the left side or the right side of the arrow. Okay, so based on what we know and what we've been told, we're going to have things that are written down. So if my formula should be NO2, then I can't turn it into N2O4. So I can't change the subscripts. That is unacceptable. We have things that need to appear the way that they're written based on the reaction that I'm doing. I can't change those subscripts. So that is not an acceptable way to fix our balancing. That stuff is fixed by either the charge on the ions or by the name that was given. That's what determines how many of each that I have. All right. So that is important. We cannot change it that way. All we can do is change the number out in front of it. Right? So one example of this, I know that I have an equation where heating KClO3 will break down to give me KCl solid and O2 gas. That's a reaction that happens. And so if I look at that reaction, KClO3 solid gives me KCl solid plus O2 gas. I have 1 potassium on each side. I have 1 chlorine on each side. I have 3 oxygens and I have 2 oxygens, and that's a mess. But I can't just come over here and make that O3. That won't work. I can't do that. Right? So we need to work on how we fix that. And for me, it becomes very simple to say, oh, well, I have to change stuff, so let me go and do, this, this, and this. And I can do it that way. But I can also do something else. K, I have Cl, and I have O. Right now I have 1 K on this side, I have 1 Cl on this side, and I have 3 oxygens on that side. I have 1 K on this side, I have 1 Cl on this side, and I have 2 oxygens on that side. So clearly oxygen is my problem. I need to fix the problem that I have with oxygen. Now, I know that oxygen has to be O2. He is a dimer. He's on his own, so he has to exist as O2. So that's not what I can't fix it by making him just O. That's not how. I can't do that. Okay. But I can say, all right, if I put a 3 out in front of this, then that changes that to 6. Right? And so then if I put a 2 out in front of that, now I have 6 oxygens. But now I've created a situation where I have 2 Ks and 2 Cl because I changed the number out in front, so I have to change the number out in front of these, right? So I changed those. Now I have to look at this guy, and there's still only one of those. So I can put a 2 out in front of this and change that to a 2 and that to a 2. Now, why did I decide to do it that way? Because if I have 2 and 3, the lowest common denominator between those two is 6. So that's why I put a 3 in front of this one and a 2 in front of this one, because I knew I could get to 6 and that would take care of my oxygen problem. And then I knew that I could say, okay, now that I've got this that way, now I have 2 of each of these. And that means that I have to fix this thing over here, and I can do that by adding a 2 out in front of that. And I know that because I have this little table that tells me, oh, you screwed this up. So anytime I change something, I say, okay, I made a change here. So I changed the number of oxygens. Now I have 6. So let me come over here and change the number of oxygens. So now I have 6. But that also changed the potassium and the chlorine. So now I have to fix that. And I know I have to fix those 2 because I changed them on this side. So now I can change them over here. So how do I fix those? Well, if I put a 2 out in front of this, it changes both of those. It's not always that simple, but that's a way for me to take care of it. I call this my balance sheet, and it works for me if I use this. Do you have to use it? No, absolutely not. Not required. Does it make it easier for me? Yes, absolutely it does. Okay, so that's how I take care of this. It gives me a way to keep track of what I've done and when I did it. Can I do it many other ways? Absolutely you can. And I don't really care how you do it. Not important to me how you get to the right answer. But having something that is systematic so that you know what you can and can't do, or what you have done and what you haven't, will make it easier for you to balance these in the long run. Okay? I'm always talking about the systems that I put in place to make things work. I'm very big on systems for making things work. Okay? It's because I want to minimize the free thinking that I have to do when I do this. I want to do it the same way every time, so that way I know that I'm proceeding in a correct fashion. So this is the way I handle this. Okay? So that's what we're talking about. We're always changing the number out in front, the coefficient, and not the subscript, which indicates how many I have in that formula. Because the number in that formula is determined by either the charge on those ions or the name that it's been given. Okay. So that's how we balance. Like I said, I can create a balance sheet to look at this. Now, one thing I have to mention to you, I can use fractions to balance equations it can be done. So if I get to something and I say, well, the only way that I can balance this equation is to put a 7/2 in front of this oxygen, I can do that. I can. There's nothing wrong with doing it. Is it preferred? No, it absolutely is not. Because once I get to the 7/2, I could multiply everything by 2 to get rid of the 7/2. So if I multiply everything by 2, then I just have a 7 and not a 7/2, right? So I can do that, and the whole numbers are preferred, all right? But I don't care if you do that. As long as it's balanced, it's fine. So you can leave the halves if you have them. I don't care. When you get into 111, those numbers will not be correct. Okay, you will never find something that has a fraction in front of it. So you will need to make sure that you have whole number balancing to be able to use the numbers that you'll find in the tables. Right? So understand that that is, again, something you won't be able to find moving forward. So be aware of that. Okay. And this should actually be 3, because that's going to bug the heck out. Sorry. Okay. I want us to take some time and do some practice. This is my expectation, is that you can look at what kinds of things you have here, and you can turn that into a balanced equation. So going from words to formulas to balanced equation, going from stuff written down to balanced equation. Either one of these should work. So I'm going to take a pause here, and I'm actually going to create a new video so that we can go from here. Questions, comments, problems at this point? Talk to you guys soon.